learning. I mean, machine learning is something I've heard a lot more buzz about recently. I went to a conference recently, and I saw a couple of startups that are doing machine learning as a service. Obviously, it's a huge part of big data. I mean, I guess, what should businesses know about machine learning? What should they be thinking about machine learning? Joelle, what's your take on that?
Yeah. So, our take is when you know what your goal is, right? So I was reading some of the backgrounds of some of my colleagues, and there's a lot of goals with big data that are about IT optimization and IT efficiency, and that's great. That's not the world we play in. We play in how do you help people discover the products they want to buy more quickly. And so the data has to be clean, but it's always changing. And the thing that is hot today, particularly in fast fashion, or anything that has any trending, the data is constantly changing. So you have to have big data applications that are set up to learn, because nothing is, I think you used the word sentient, but I'd say static. Nothing is stable, right? Not even the way people put their structured data together is stable, because if they get a new manufacturer and they send the content a different way, there's always change. So you need to be thinking about what are the levers, if you will, for machine learning. So a lever could be how users engage with, a lever could be pricing changes, learning about, one of the big ones in our space for our customers is learning how products are moving and falling in inventory, so that you can adapt what is discovered and what is presented, so you don't present things that have just sold out. So the system needs to be learning from each individual, from each business, and from the entire web to solve a specific problem. I don't think we should leave Donna's opening point, which is you have to know the problem you're trying to solve. Big data is kind of like saying, I have a hammer. Great. Now what?
What nail am I going to pound in with it?
I haven't even gotten to the nail. I just have this hammer.
Right. Mike, your sense of machine learning, what people should be thinking about, be aware of when it comes to big data?
Well, I think the first thing is anybody that's going to tackle machine learning has to have executives or stakeholders or sponsors that actually understand a modicum of data science, enough to say, I understand what a lift curve is, or a rock curve, or a confusion matrix. And it's a couple hours of internal training, but you can go really badly wrong with a misunderstanding at an executive level of what machine learning is actually doing. So I would caution people about that. And then I think just in terms of big data, there's a couple different approaches. Maybe we'll hear a little bit about this. So there's things that are easily parallelizable, not paralyzed, on Hadoop. And then there's things that require more of a high-performance computing architecture, like simulations and so on. So it's important to also recognize not all machine learning can be done with every architecture, but more algorithms are being ported to more commodity forms of machine learning. And finally, machine learning and really everything going on here is really about discovering correlations and learning behaviors, not necessarily finding causation. So I would caution people to really just understand statistics and probability and a little bit of that. That if you're looking at machine learning, you understand a little bit about why things might have happened, and you can recognize things that will happen in the same way again. It doesn't prepare you for situations you haven't seen before necessarily, and it doesn't really give you necessarily that underlying causation. It just gives you strong correlations. So,
I think you use the term confusion matrix.
Yeah, very confusing to me. But I think that's one understanding that any type of machine learning algorithm is basically making a prediction of something. It's a model of the world, a model of some question, and it's going to come up with true positives and true negatives when it gets the answer right, and it's going to come up with false positives and false negatives when it gets the answer wrong, either wrong one way or wrong the other way. And you put those four numbers together, you get a matrix that you can derive a lot of accuracy scores with about the machine learning model.
And that is the confusion matrix.
That's the confusion matrix, right? Okay.
I'm going to use that term. I really like that term.
This is a data science term for all of you today. Yeah, go ahead.
Yeah, well, but if I can jump in on Mike, I mean that's why you need massive. I mean, this is where we go. Massive amounts of data is in order to get those predictions right. You need to be looking at them over large data sets. because often you're making minute predictions that in a smaller data set you won't get statistical significance.
Right. You need as many respondents as possible over time.
You do.
The three V's. We can't talk about big data without the three V's: volume, variety, velocity. Sanjay, your sense. So, are you going to add something, Mike?
Oh, I was just going to say, I think we added up 15 of those V's at one time when we did a survey of the market.
Right.
The variety of just a whole bunch of things having to do with every vector you can imagine. So basically, we look at big data as data that you couldn't be processing before on your traditional legacy architecture, and now you've unlocked this, whatever the vector is.
Sanjay, machine learning. What's really important for people to know about machine learning as they move forward with their big data application?
Yeah, I mean, I think one of the key tenets of sort of machine learning is the idea that the data is going to tell you something, as opposed to you as a human being writing rules all the time to get insight out of the data. And so it goes back to the point that I think we were discussing earlier around pairing human insight with sort of machine learning. The notion of machine learning in a big data setting is that if you don't know your data well enough to even know what questions to ask, machine learning is an incredibly useful tool to provide insights around what might be anomalous, what might be pertinent to a particular subset of users, etc. And then you add in the human dimension around saying, well, do I care about that or not? Because you may decide that as a result of machine learning popping up anomalies in your infrastructure, whether it's on the server side or a new custom application, you may decide to do nothing about it. But that's the human judgment that you get as a result of interacting with that machine learning. So, we use it from an IT perspective to help our customers understand what might be interesting patterns and anomalies in their data. But without the business context, you don't know whether those are relevant or not the first time you see them.
Donna, business context and the machine learning. What's important to know about machine learning?
Yeah, I mean, I hate to keep going back to it, but I think it's all about sort of what your problem is you're trying to solve in the use case. I mean, one of the areas where we found machine learning has become really important is in this concept of, getting this better view of your customer. Oftentimes, I hate to say it, but in the older days, referred to as the 360 view, we all hear about it, but it's really about customer behavior, and it's about really knowing what is the application of that machine learning. So if we think about customer behavior, one of the algorithms that becomes important is being able to score data, right? But again, it needs to be part of that whole data flow process, as Joelle was mentioning. Part of the power of machine learning in the context of big data analytics is we have volumes of data now that can actually refine those models and tune them to the point where they can be pretty accurate. So I think it's thinking about machine learning in the context of the bigger picture of what's the problem that you're trying to solve, and then seeing where it's applicable in a specific use case. So as I mentioned, scoring becomes very important in looking at customer behavior. And that's what we found, is that really tying that into that whole data flow and the integration of these different data sources and managing these big data sources where it becomes really valuable and really powerful from a business standpoint.
I think about machine learning. I'm reminded of that scene from 2001: A Space Odyssey, where the machine says, "Sorry, Dave, I can't do that, Dave." He actually will not let the space guy back into the machine, back into the ship. I guess basically the machine at that point had taken in so much data that it realized that it should no longer have human intervention. I guess we're headed towards that way at some point.